Recording in progress.
A very good afternoon to all. Welcome to the afternoon sessions of Day 2 of the International Conference. Now we are having an international fame, Professor Dr. Roy Wagner, Professor of History and Philosophy of Mathematics from ETH Zurich. His topic of presentation is the content and context of Kanakadhigaram treatises. As Professor Roy Wagner has some inconvenience to present the paper, Mr. Arun Ashokan, postdoc at the Chair of History and Philosophy of Mathematics, will present the paper on behalf of Professor Roy Wagner. Then the last session of the day will be handled by Dr. Sujay Kumar C.K., Assistant Professor, Department of Sanskrit, General, Sri Shankaracharya University of Sanskrit, Regional Center, Koilandi. In order to deliver the official welcome speech, I call upon Dr. Parvati KP, Stride Coordinator and HOD of the Department of Sanskrit. Teacher, please. Yes. Thank you, Parvati teacher. Thank you. So let us move on to the sixth session. Kanakadigaram, a Malayalam treatise on mathematics, is less explored treatise. It is in the form of songs that explains basic aspects of mathematics. So with the intention of exploring the treatises, we are having Professor Dr. Roy Wagner to present the topic content and context of Kanakadigaram treatises. Professor Dr. Roy Wagner is basically a mathematician, and later he was interested in history and philosophy of mathematics. It was Professor Dr. Roy Wagner who took all the initiative to come up with a revised text on Kanakadigaram. With his deep knowledge in mathematics, he will definitely make us understand what is Kanakadigaram. I use this opportunity to thank Professor Roy Wagner for taking such a big initiative to bring these treatises to the light. Otherwise, it would have remained in some corner of our library. Along with Professor Dr. Roy Wagner, I also call upon Mr. Arun Ashokan, who is the co-author of this paper. In the beginning session, I wrongly said that Mr. Arun Ashokan is presenting the paper on behalf of Dr. Roy Wagner. It is not right. I'm sorry. He's the co-author of this paper. So, and I know that Mr. Ashokan, a very simple and humble Malayali, was close associate of Professor Dr. Roy Wagner in his efforts to revise the Kanakadigaram treatises. So I also express our sincere gratitude to Mr. Arun Ashokan also in this time. Over to you, sir, to have a great presentation. Sir, please.
Can I share the... Thank you for inviting us to this webinar. Today, I am going to present. Am I audible?
Yes, sir.
Today, I am going to present Malayalam Kanakadigaram, vernacular mathematics in medieval Kerala. This talk is based on a joint work of Roy Wagner, Arun Ashokan, and Vrinda PM. Malayalam Kanakadigaram is the most commonly surviving treatise on practical, commercial, recreational mathematics in Malayalam that enjoyed substantial distribution in medieval and colonial Kerala. Before entering to the content of Kanakadigaram, I think we need to know the historical background of the production of the Kanakadigaram treatise. The period of this study is start from 14th century to 17th century. Medieval Kerala society hierarchically stratified by caste system in those periods. This hierarchy was regionally varied, but one can loosely consider Brahmins as the most privileged of the top of the hierarchy. Then temple-oriented caste, Nayars, Idava or Tiyas, artisan caste like Ashari, Mushari, and Kollan, Kanyan, and slave caste, the most unprivileged section of the society. This is the stratified system of society. Along with these caste groups, the religious groups like Muslims, Christians, Jews, Jains, and Buddhists were very active in the time of medieval society. The society was Just like society, the political system also highly fragmented. Uh, the principalities or the little kingdoms will fight each other to prove one's power on other. And it was the time of dissipation of trade guilds like Manjuvarnam and Manigramam, Anjuvarnam and Manigramam. And this also was the period of beginning of colonialism. But the traces of colonialism was not appeared in the mathematical treatise of Kanakadikaram. While talking about Kerala culture of those periods, we need to consider three languages at a time: Tamil, Sanskrit, and Malayalam. We know that Malayalam born out from Tamil and Sanskrit, and it heavily borrowed from Tamil and Sanskrit to flush out its life. The Malayalam Renaissance inaugurated translation from Sanskrit to Malayalam, but those were less grammatically and periodically codified than in relation with, if we consider with Sanskrit and Tamil languages. Until 19th century, there was no grammatical treaty in Malayalam. The literary production or the knowledge production of those period was under the patronage of political agencies like little kings. And there was a slight competition between scholars. But it was not like a quotation culture which centralized by the authority of king. And in quotation culture, the protection of knowledge is centralized by the authority, under the authority of king. That we can see in the other South Indian kingdoms of medieval period. The medium of preservation of knowledge was palm leaf. We know that palm leaf was a very fragile and soft-living medium. So one need to rewrite and re-record the knowledge to other copies to preserve the knowledge of those periods. And a transmission of knowledge was mixed by oral and written culture. The verses recited, and that recitation was clubbed with writing of the verses in palm leaf. So it is a mixed kind of transmission. More interestingly, those periods, the knowledge transmission also and production also linked with the performance. If we consider the Shastra Patu, one of the genre of scientific knowledge of Malayalam, the Shastra Patu, text of Shastra Patu was performed by people in front of audience to prove their veracity and scholarity. This is the manuscript we are working on, we have been working on. In those periods, the educational system of Kerala was not well codified, and we have very less proof about that in historical records. But we can loosely classify those as Brahmin schools, that means Salai, Gurukula, and Mada. The Brahmin schools runs a school exclusively for Brahmins, and temple-oriented communities by temples, Brahmin families, and rulers. Teachers were mainly from Brahmin community, and few of them are from temple-oriented communities. And the another school is non-Brahmin village schools, Eluthupalli or Eluthukalari. Those schools are run for Nayars and Avarna caste. Teachers were mainly from Eluthachan and Kaniyan communities. Those communities were lower caste polluting communities. In those period, teaching of mathematics, memorizing by chanting, in the case of Injivadi and other texts, there was a dialogue problem solving. Teachers ask questions and students answers to that questions. This is the sample of Kanakadikaram, which we have been working on. Let us look, what is Kanakadikaram in its content? Kanakadikaram is a combination of two words, Kanakku and Adigaram. Kanakku means number or calculation. Adigaram means rule or treaty. Therefore, we can read rule of number or treatise of calculation. This is not a single text which produced or available in different forms. It is a family or genre of versified elementary mathematical treatise in Malayalam. Language of this text was Malayalam, 15th century Malayalam part 2 verse with Malayalam prose commentary. The content of this treatise are not clearly marked in under subtitles in these Kanakadikaram manuscripts which we have. But if we read closely, we can see that these are the content. Invocation and content declaration. Invocation is the praising of God or supreme authorities. Content declaration means the statement of the content or table of the content. And fraction and decimal powers. Unit of measurement, that means the unit of weight, volume, time and distance. Calculation techniques, rule of 3, place value multiplication of decimal powers, summation of finite series. Here, rule of 3 is very unique for Malayalam manuscripts. It is coined by very attractive words. Talla Pilla Perumal. Talla means mother, Pilla means child, Peruval means expecting mother. Here, summation, if you consider summation of numbers from 1 to n, square of numbers from 1 to n, cube of numbers from 1 to n. This result of summation of each step are compared with a checksum. Therefore, it prevents possible mistakes in copying. Perhaps the coexistence of practical mathematical table and the Sangalida maybe reflect the relationship in between the vernacular mathematics of Malayalam and Kerala school. And we have a problem section in these manuscripts. It deals the pricing and barter, gold mixing that in different quality and quantity, wood measurement of log and planks, land measurement, interest calculation, and miscellaneous problems which with interesting narrative strategies. Version, we have three kind of versions of Kanakadigaram. One is Tamil. Those versions are attributed to 15th century author. Most probably, he is not an author, perhaps a copier. These manuscripts are surviving in various manuscripts, and these have print edition in 19th and 20th centuries. Malayalam manuscripts are unattributed to any particular period of time and any authors, no colophons. Those manuscripts survive in a few manuscripts. We have 5 in our hand, which we are working, and we know that 3 or more, 2 or 3 or more are preserved in regional manuscripts libraries of Kerala. This Malayalam Kanakadigaram has a print edition in 19th century by Mavanar Sayyid Muhammad Mapila. So one can call it as a Muslim print edition. These versions are substantially varied. A few words in the number metrology section are the common core. Several other related treatises, most prominent among these is Kanakku Saram. And we have another two, this Kanakku Shastram and Kanakku Chodyam also we have. The Kanakku Saram stating that it combined Kanakadigaram and Nilavadi in its production. But if we go through the Kanakadigaram manuscripts, despite the common clay, we can see that Kanakadigaram has very little to do with Lilavadi. That means only handful of verses adopted from Lilavadi to Kanakadigaram, and those verses present in a very corrupted form. Let me present few words from this Kanakadigaram treaty to give a picture about verses. Let me start from invocation. I will read the Malayalam, then English translation. Panangalil Ariya Panamudaya Nagate Padarchidayil Chudi Irunna Arulunna Sri Mahadevanu Polum Pinakkarudatha Vannam Perima Chendulingi Chendi Oli Vilangi Irikuna Kanakadigaram Avunna Kavide Padichi Chuvan Aikondu Tuna Chedu Aga Karimugan Avunna Ganapaditan Ennavaru. Ganapati, the elephant-faced himself, helped me learn to recite the poem Kanakadigaram, whose greatness shine brightly, which is difficult to compose, even even for the blessed Supreme God, sitting crowded with sitting crowned a hood-wearing snake, which is more excellent than a hood of his matted hair. So it is said. Here we need to notice the word greatness. It suggests an holy or sacred origin of this knowledge. The content verse, it is a table of content of the Kanakadikaram. It appeared almost all verses, all versions of the manuscripts. Adi nilam pon nell arishi akalidathil. Beginning with land, gold, paddy, rice in the whole world. Needi tharum kal kallum near irayai, giving the just kal kallu in the right sequence. Here, kal signifies the capacity unit or the measure of distance. Stone, perhaps it is a weighing stone. Here, near irayai in Tamil, it means, oh, adored girl. It is different from Malayalam actually. Odayaruppadum aga chamachen onnuriyadavanam. I created the entire completed recitation without omission. Medil arabadu kadal kai adattu ponnen ennavare. I completed verses for the 60 essence. That means mathematical subjects in the world. So it is said. Here, we need to notice that this content table is not thoroughly reflected in the text. That means the 16 words and the 6 subjects is not a template of the content of the manuscripts which we have. Perhaps in one manuscript of Kanakadikaram, we may found 50 verses. In another, we could find 100 verses. This disparity and this is very visible in all versions. Linguistic characteristics. The language is irregular versification, corrupt orthography, copies sometimes can't make sense of what they are copying, also mathematical mistake and miscopying. The language is relatively highly Tamilized. The poetics is less sophisticated with loose poetic rules and vague meters. Why this inconsistency of language? The possible explanation on the inconsistency of language is primary oral tradition with poorly codified orthography or morphology. Migration between different Malayalam dialects. Copying by non-expert. Transition from Kolalithu to Grantha. A temporal hiatus where the text was not studied or copied. That means this last one is a speculation. We don't have any proof about that. The possible origin of the verse are here. It is not possible. It is these verses are originated from three different registers, predominantly two registers, one can say. But let us see what is the location of origin. Relating to Tamil, a few words are clearly adoption from Tamil, and as indicated before, those verses are corrupt and senselessly adopted. Other words could migrate from either a way. Most Malayalam words have no Tamil counterpart. Relation to Sanskrit and Prakritis. Some similar topic divisions and problem families sharing with the Sanskrit and Prakritis, and a handful of problems traceable to Lilavati, but those are copied or those are adopted in a very corrupted form. So the majority of the words in Kanakadikaram treatise are Malayalam in its nature. One can say that this very little it derived from Tamil and Sanskrit. If we consider derivation from the Tamil and Sanskrit is very less. The origin of these words are mixed origin. That means if we consider the poetic style of the verses, we can say that it reflects 15th century southern folk poetry style, Deccan poetry style. It, just like the Ramacharitam and other, but more than Ramacharitam, I think. But content, if we consider the place name and coin, it fit the 15th century Calicut area. So we do not have proof to say that this text is clearly produced from a geographical location or a very particular time period. The origin of the verses are mixed with different locations and different temporal frames. If we look the use of the text, we can say that it was used for educational purpose. Because this text structured like a textbook manual, procedures applied to exemplary data and dialogic problems. This Kanakadigaram used for second stage of child's mathematical education after mastered Injivadi, that means multiplication table, sometimes collated with Injivadi, that means one of the manuscripts we have is collated with the Injivadi. Then one of the copier of the manuscript was from a traditional teacher. So these are the proof we have to argue that this manuscript this Kanakadigaram treatise are used for educational purpose. We are unknown about target audience, which caste, which profession, which group they were. Some of the knowledge probably derived from craft contest, but adopted to the point of view of merchant, accountant, and teachers. This is very important because the problem of the Kanakadikaram is about gold problem and rice problem and wood problem. If we consider it is in its nature, it is related to craft. If it is so, it would be narrate in the point of view of artisans. That is not happened in the narration of the verses. Rather, it narrated in the point of view of merchants or accountant or teachers. That means abstraction of real craft commerce situation to the codified calculation, veracity of verse and problem, that we can see that unrealistic numbers, unrealistic situation narrated in a fancy settings. If we consider large and small numbers, a list of large numbers of 10 is appeared in Kanakadikaram treatise. This is prevalent in many Sanskrit treatises, but the Kanakadikaram list is remarkably unique. This power of 10, which appeared in Kanakadikaram, is very close to the Jain Buddhist version than Hindu. If we notice the suffix of the power of 10, few of the units, we can see Maha is the suffix they used. For example, Kodi is followed by Mahakodi. This is clearly indicate that the connection between Jain version and Malayalam version of power of 10. Several list of very small numbers. We have small measurement in Sanskrit treatise, but here the Kanakadikaram has list of small numbers. Standard scales follows. Follows fractions. The white fractions are main. The gray are derived from white. Lower scales. Some fraction of 1 by 320. Sometimes we can see a third scale too. Then divided into 21 immi, and then things get strange. Beyond immi, 7 anu, then anumavu, osha, sabadam, mada, tari, tuli or dhuli, drishtam or drishtam, adrishtam or adrishtam, anumavu, timiram, talparam, chadiram, muttu, chinni, tatta, takkada are the lower division of the numbers. The small numbers are in all versions. The numbers are varied and inconsistent. Some echoes, Sansa scale, many terms doesn't make sense. None of these are used in problems section almost. Measurements. Time measurement units start from Brahma's day, then Kalpam, Manu age, Chaduryugam, then a divine year, then human year, day, Naliga, Virpu, Kanitam, Matra, Kanima, Kainodi, Alpam, Tudi, Kala, Kata, Kalam. Here, we need to notice that human year, day, Naliga, Virpu are the time units used in problem section of the Kanakadikaram manuscripts or Kanakadikaram treatise. The only green one actually used in problems. Distance start from Yojana, Kadam, Kuvida, Tendugol, Murakol, Muram, Chanam, Thoraviral, Nelli, Ellu, Cherukadu, Viral, Varimanal, Mummanal, Mayurmuna, Tertugal, Vanjituli, Anu. Here also, the distance units like Kadam, Kol, Chanam, Viral are used in problem section. Only used in problem section. Weight start from Param, Tulam, Palam, Karanji, Kanam, Visam, then again Karanji, Kalkaranji, Manjadi, Kunni, Mulagu, Visam. Here also, in problem section, we can only see Param, Tulam, Palam, and Karanju. Then the volume units. Volume units start from Kalam, Para, Tuni, Padakka, Kurani, Idangari, Nari, Nari again, Urakku, Arakku, Chavada, Turumam, Tuli, Vindu, Kanam, Inakkanam, Neyi, Pali, Tumam, Manam. Here also, as I said before, Kalam, Para, Tuni, Idangari, Nari are the units used in problem section. Only units used in problem sections. Here we can clearly observe that variation and inconsistency between versions, sometimes between two words in the same treatise, sometimes in a single verse. Hardly any attempt to localize variance. We have a verse about localized variant, but it is not about a measurement unit, it is about conversion rate. It is that is the one verse which signified about the special remarks. These are clear overlap with Sanskrit tradition, measures actually used in Kerala. But also lot of deviations and idiosyncrasies. These measurements are overlap of Sanskrit tradition and measurements actually used in Kerala, but also lot of deviation and idiosyncrasies. This many of the measurement units appeared in Kanakadikaram treatise are too small for practical use. Most units are not used in problem section. Some units used in problem section are not in the introduction. How to explain this nature, the strange nature, the complex nature of Kanakadikaram? Practice. Measures are unstable. That means different regional measuring scales. The same measure name has different value in nearby places. That means in the measurement which appeared in Valluvanadu, for example, the para of Valluvanadu is different from the para of Ernaடு. In architecture, measurement used to construct house are relative to the owner's body. The regional different in regional measuring scale is not a unique thing to the medieval Kerala. If we know the men and measure, one of the classic of about the measurement clearly state that in medieval Europe also this measure was regionally varied. In the context of power, that means the expression and production of knowledge of mathematics was an act of domination. For example, the evaluation is an act of domination. Evaluation and taxation are not reducible to objective calculation. For example, land value is determined by a council of four, by greedy estimate of robber baron tax collectors. This was the context, medieval context. In the context of the meaning of the numbers has esoteric meaning. For example, auspicious proportion in architecture, number in astrology. But this esoteric meaning has almost no echo in Kanakadikaram. But we think that perhaps the esoteric nature was the reason behind the strange appearance of the measurement units. From these significations, we can conclude that Kanakadikaram knowledge involves a juxtaposition of practical knowledge, esoteric knowledge, the authority of accountant, veracity, the symbolic capital of teacher, student, or performer. So practical knowledge means the knowledge related to the craft, production of craft and commerce. Esoteric knowledge means knowledge makes certain kind of magical or spiritual effect on population. It is an attempt to make a classical or pseudo-classical local notion of mathematical knowledge. The authority of accountant, yeah, it is very clear in the word, in the title of Kanakadigaram. Kanakadigaram means, Kanaku means accountant, and Adigaram means authority. So perhaps it reflect, this knowledge reflect the authority of the accountant. Different kind of veracity. This knowledge express different kind of veracity by memorizing the verses. It express the ability of memory of one, and this express the calculation skills, and by singing or chanting the verse, they express the aesthetic pose. Then the symbolic capital of the teacher, student, performer as possessor of knowledge that is not reducible to practice. As we notice in the beginning of this presentation, perhaps we know that it was the medieval society of Kerala was highly fragmented in the line of politics and in the line of administration and in the line of sociality. So perhaps the Kanakadigaram Treaty is an attempt at imposing a wide-ranging order in a practical political reality of unstable measures and value, or a ironic expression of critique against lack of order. These are the possible explanations we can present in front of others in this point of time. Thank you. Thank you for your invitation. Hello?
Yes, sir. Thank you so much. Thank you so much for your brilliant presentation. Now, shall I call the participants to ask questions?
Sure, sure.
So this is the time to ask questions. Your queries are welcome.
Yes.
Anybody is having any question, doubts regarding Kanakadigaram?
Good afternoon.
Good afternoon. Good afternoon, Ardra.
Myself, Ardra. I am final year BSc Maths student of Sri Vishnupuram E.T. Bhattathiripad College. First of all, thank you, sir, for your wonderful presentation. As we all know, mathematics has been an indispensable part of our life. And is there any contrast between vernacular maths and Sanskritized mathematics in content? And whether deeper level calculations are in Sanskrit language text? Sir, please.
Yeah, the primary difference is that I think that Sanskrit mathematical treatises are codified and it is somewhat unified to its language structures. that kind of codification not happened in the case of Malayalam because of the fragile nature of the uh, language, because it was not uh, codified grammatically and prosodically very clearly. And it was a discursive formation, not just like a author produced text, which we used to see in the historical background of Sanskrit.
Thank you, sir. Thank you. Anybody else?
Thank you so much.
Anybody else having questions?
May I have a question? May I ask a question?
Of course, sir. Of course.
So first of all, I'm very happy that the Karnagari is and this class of treatises is being studied. I followed the recent editions in Tamil of these works, and I'm very look forward very much to what we'll come up with these new versions that you have found. So there are a couple of questions. First of all, I only know the Tamil versions, that is the 2 volumes of Karnagadigaram that were published in Tamil in 2007 or something like that, and also something called Ganida Noor that was published by the same people. And there are 2 things that are clear from these texts. First of all, the Tamil versions pretend, and they explicitly said that they are based on Sanskrit words, and the editors have listed a number of words. The one that comes up most often is something called Astronomical, but there are other titles that are mentioned. I have never seen these treatises. So the first question is, do we have any trace of these things in Sanskrit or in Malayalam somewhere? The second question is, again, the editors mention, I don't know whether it is in the Karnagadigaram or in the Ganida Noor, that the manuscripts actually don't completely write out mathematical operations. They use a notation for operations, and they give some examples. So it would be very interesting to see exactly what this notation is, if it is attested in for instance, in Malayalam or in other sources that you have seen.
Thank you for your questions. If we consider the influence of Sanskrit mathematics in Kanakadigaram, we can clearly notice a handful of verses from Lilavati in Kanakadigaram. But those are very poorly copied, or those appeared in a very corrupted form.
Right, it doesn't look like the Lilavati at all. I mean, anybody who has read the Tamil Karnagadigaram said that it has almost nothing to do with Lilavati, so I fully agree with that.
Yeah. And we do not have any reference about Asthana Kolahalam in our Kanakadigaram, actually. And as I said before, a majority of the verses are not signifying any any kind of master text, or we can say that those are not derived from Sanskrit.
Right.
Am I correct right now? Am I audible?
Yes. No, I mean, what I found in I'm only talking about the Tamil version because I don't know anything else. But when you read the Tamil version, it has nothing to do with, there are really differences. For instance, even when you talk about Trairashika and things like that, you don't have the same notation. There's the first, second, third, the fourth, and fifth, and there are even notions that are common to Lilavati and Karnagadigaram are not explained in the same way. So clearly this is something different. But if you look at the introduction itself says that it has taken the sarang from other texts and things like that. I mean, that's probably because of legitimation or things like that. But if you look at the foot, there's a long footnote that gives 4 or 5 titles of texts that are supposed to be sources of these things. So we'll be extremely interested to see whether these texts actually exist or not. But and for instance, you mentioned the large numbers. I mean, there is something that goes even earlier than that. In the Parivarta, there is a mention of large numbers, of large powers of 10 that occurs. And this seems to be something that is mentioned in the Tolgapian about when Yeju is combined with the words that end in A.I.A.M and Al, that is Ambel, Verlum, and Tamare, and things like that. So obviously there was something like that that existed a lot that had been studied for a long period, or a long time before the 15th century, and it would be extremely interesting to find traces of that either from Kerala or from Tamil Nadu.
Yeah, thank you.
Thank you, sir. Thank you so much for making this session more interactive. Thank you so much. Thank you, Arun Achogan, sir. Now I call upon Mr. Sankeet Krishnan from BA Sanskrit to deliver the vote of thanks.
Thank you. Thank you.
Thank you so much. Thank you so much, sir.
Thank you.
So the 6th session of the conference is over. Now move on to the 7th and the last session of the day by Dr. Sujay Kumar C.K., Assistant Professor, Department of Sanskrit, Sri Shankaracharya University of Sanskrit. The topic is astronomical speculation reflected in Dashadhyay of Talakkulattur Govinda Bhattadri. Dashadhyay is the famous reputed commentary on the first 10 chapters of Varaha Mihira's Brihat Jataka by Govinda Bhattadri of Talakkulam. As man is eager to know the future, this treatise has got much importance. Here we have Dr. Sujay Kumar C.K., who has done a lot of research work on the Dashadhyay. His PhD topic itself was critical study on Dashadhyay. He has published 5 books on astrology and 15 articles on various topics, more than 15 articles on various topics. We welcome you, sir, to handle the session. Over to you, sir. Please.
Thank you. Audible, no?
Yeah, audible. Very much audible, sir.
First of all, I thank to our team, especially Parvati teacher, Dr. K.P. Parvati, to give me a chance to present a paper in front of you. Thank you. And now, astronomy, we know, last these 2 days, we are hearing about astronomy and mathematics in India. Anyway, connecting with this topic,
Yeah, no.
the Dashadhyay, hello?
Sorry.
Dashadhyay is the most popular work, especially on the ground of Kerala astrology. So, astronomy is an observational science that may be the first science due to its impact experienced everywhere in the world. The 9 planets are clearly enumerated in ancient texts that identified and discovered ancient preceptors through the pure observation and experimentation with the naked eyes, using the intellectual power and logical thinking long years back. Taittiriya Aranyaka clearly said, Smriti Pratyaksham Aidhyam Anumanam Chatushtayam Aditya Mandalam Sarvairapi Vidhasyate. So they were using actually 4 pramanas to find out such things: Smriti, Pratyaksha, Aidhyam, and Anumana. Although the astronomical reflections are seen in the Vedic age, this tradition has been continued till 12th century and extended it in Kerala up to 19th century. On the ground of Keralite astronomy or astrology, the first Sanskrit commentary, the Shadhyai of Talakulathur Govinda Bhattadiri, is unique by its scientific nature and methodology applied in it. Actually, the Shadhyai, the text, when we examine the text, the Shadhyai of Talakulathur Bhattadiri, he tries to impress the what is the scientific background of each theory. Especially the text is introducing astrology, but astrology also exists with the help of astronomy and especially mathematics. And so he tries to speak. That is, although it is included in the topic is astrology, but he tries to find out so many scientific theories. What is the planet? Such type of information given in the text. Anyway, just I am sharing the document. Astronomy and astrology through the ages. Just I am introducing what is the nature of astronomy or Jyotishashastra through the ages. Astronomy or Kalavidhana Shastra, as it indicates, it was applied it was applied to clarify time to perform Vaidika karma or yajna in Vedic age. The wording Jyotishastram vadatyatra kalam Vaidika karmanam and Vedahi yajnartham abhipravartaha kala anupurvya vihitascha yajnaha tasmadidam kala vidhana shastram yo jyotisham vedasa vedayajna. The popular sayings we know that it is actually astronomy Jyotishastra in Vedic age that was doing that for Vaidika karma. You know that. At the same time, by this statement, it may be assumed that the Muhurta was prevalent at the Vedic age of at the age of Veda, that Dashadhyayi clarifies as Tatra Muhurta Shastrani Pradhanaihi Kritani. So, Jyotishastra tradition, we can divide it into 4 stages. First one is Vedic age, second one Vedanga age, third stage is Epic age, and fourth one is modern age. In Vedic age, we know that so many quotings. We can see the exemplified a number of astronomical and mathematical theorems disorderly scattered in Vedas, Brahmanas. There has been recorded such type of information in his book entitled as History of Science and Technology in Ancient India, the Beginning. About the technical knowledge was applied well from the age of Indus Valley civilization on the ground of study of bricks used, the yagas that mainly was based on Shilpa Sutra and Shatapatha Brahmana. The people of Vedic age were well aware on astronomy and mathematics. Some examples are given there. The 27 constellations, like that, the solar system, the movement of celestial sphere, Vishuvat, equinox, Ahoratra concept, the Yuga concept, the circle announced was a time or Kala Chakra, as it contains 12 zodiacal sign of 30 degree and the like. Chakrana Sabarinaham Prithivyaha Hiranyena Manina Shubhamana Nahinvana Sasti Rutasta Indram Patisparsho Adathat Suryena and Savita Yantrehi Prithvi Maram Nada Astambhane Savita Dhyamadrimhata and like so many quotings we can see the in Vedas and Brahmanas. The Taittiriya Samhita and Aitareya Brahmana underline that clearly as respectively by describing Ekavimsha Yaga is performed on the equinox day occurring in the middle of the year, known as Vishuvat Tasmad Adityata Shanmaso Dakshineneti Shadutarena. Taittiriya clearly says this statement. And one more, Etadaharapayanti Madhye Samvalsarasya. Next, in Vedanga age, at the age of Vedanga, astronomy is developed. Astronomy developed as a discipline of Vedanga or one of the auxiliary disciplines on the basis of the theory applied in Vedas and Lagathas Vedangajyotisa. We know that after the Vedic age, next stage or astronomy, a systematic astronomy, we can see in Lagathas Vedangajyotisa. It is the first authentic astronomical work after the Vedic age. After the Vedic age, Vedangajyotisa of Lagadha was the first systematic work exhibits astronomical calculation in which accurately recorded the duration of Yuga and solar years, lunar years, sidereal cycles, and synodic months, etc. Jyoti and at the same age, astronomy flourished with its branches such Siddhanta, Samhita, and Hora. The last one, Hora, flourished by the same stage by its old limbs. Dashadhyaya records it as Jyotishastram Aneka Bheda Vishayam Skanthatrayadhishtitam Tat Karsnyopan Upanayasya Nama Mundibihi Sankirtyate Samhita. Tadvadeva idam Jyotishastram tavad triskandham tatregas tavata ganitaskandham aparas samhita skandhaha tritiyo horaskandhaha skandhaha. So Jyotishastra actually divided into 3: Ganita, Samhita, and Hora. Hora after that divided many Prasna, Jataka, Muhurta, Ganita, Jataka, etc. The new word astrology, prediction part or predictional part, is contributed by Westerners, which is derived from the two Greek words astra and logos, meant logic or reason, which exists only depending on astronomical and mathematical theories. Middleton has said it in Indian astronomy. In India, astronomy is closely associated with astrology. Astrology is sometimes taken for astronomy, but two are different. Former is visible and later is invisible. To an extent, however, both are complementary to each other. So astronomy and astrology both are different topic like now. But in ancient time, it is known as Jyotishastra. Without astronomy, without mathematics, no astrology or predictional part. Epic age, Jyotishastra in epic age. Epic age, so many examples we can see there in Ramayana and Mahabharata. After that, so many dramas and poems, kavyas. We know that especially Kalidasa has quoted so many astrological and astronomical notations in Mahakavyas, in his Mahakavyas dramas and Khandakavyas, etc. And Ramayana, we can see an example just after their marriage, when Sita joined Rama, their union has been described by Valmiki as Rohini getting elated on the arrival of the moon. Rohini Vashasankena Rama Samyogamavapa. And another example is there in another context. Is mentioned that Ravana carried away Sita as Mercury does. Rohini from the sky. Abhigamya Sudushtatma Ratasa Kamamohida Jagraha Ravana Sitam Buddha Revehe Rohini. That horoscope of Rama, Lakshmana, that also we know that about that evidence. Jyotishastra in modern age. In modern age of astronomy and astrology, modern age of astronomy and astrology is concerned with the correlate astronomical tradition that may be recorded although from the age of Varaji 4th century AD. After the astronomer Haridatta, Govinda Swami, Shankaranarayana, and Suryadeva Yajwa at the age of 12th century AD, the preceptor on Jyotishastra, Talakulathur Govinda Bhattadiri, the scientific tradition has been recorded systematically, and this tradition has been continued up to 19th century AD. Lagadha, first millennium, I produced the age famous astronomers up to Govinda Bhattadiri. Next. Date of Talakulathur Govinda Bhattadiri. The date of Talakulathur Govinda Bhattadiri is still in controversy. Scholars are of different views about it on this. Kotarada Shanguni considered both Villamangala Swamiya and Govinda Bhattadiri as contemporary. Some other scholars like Acharya Narendra Bhushan has attributed that the time of Govinda Bhattadiri may be in 13th century AD. And we have concrete source from Ulur Parameshwara Iyer is represented as the Kali chronogram as Rakshit Govinda Markaha and Kalindi Priyatushtaha. Based on these two Kali chronogram Vakyas, we know that actually he was in 12th century age of Bhattadiri. It may be 12th century AD. Next, works of Govinda Bhattadiri. He has written 5 works. Dashadhyayi is the first one, and Muhurta Ratna. Next one is Govinda Pathati. Next one is Tamara Nellur Bhasha or Tarana Nellur Bhasha, both are famous. And Muhurta Padavi. Among this, Muhurta Ratna is published And the Govinda Paddhati is also published. It has a commentary. A.I.A.M by Kanipari Shankar Nambaripada, Kunagalam, bookstore. Actually, Govinda Paddhati, there is doubt whether it author of Govinda Paddhati is it attributes to Talakurtur Govinda Paddhati? It's very doubt. Anyway, Govinda Paddhati is astronomical mathematics, actually connecting with astrology. It is interpreted in the, and so I think it may be the authorship of this Govinda Paddhati into Talakurtur Govinda Paddhati. Next one is Tamaranallur Bhasha, and Muhurta Padavi is also like that. There is a doubt. Next, Dashadhyayi commentary is written by Bhattadari was meant only for his disciples, and so the language and style are simple but comprehensive with all sections of Jyotish Shastra. Bhattadari says, Naisha Panditya Prakadanaya Krita Swagada Arthan Mandabudhaye Shishyaya Vadeshtumeva. The work Dashadhyayi is unique than any other commentaries wild, especially in Kerala. Bhattadari wrote this commentary only for 10 chapters, but that was sufficient to interpret the total text of 26 chapters of Brihajjataka. Varaha Mihira Hora Shastre Prathamadhyayad Arabhya Adhyaya Dashake Maya Vididarthaha Prayashotra Vyakhyataha Uparidanadhyayaha Adhyaya Arthascha Kechita Vyakhyataha. His quoting is given there. This commentary is rightly valued by the verse Prasna Marga Adrishtva Yo Dashadhyayim Phalam Adeshtum Ichhati Ichhatyeva Samudrasya Karanam Saplavam Vina. Next, methodology and scientific representations applied in Dashadhyayi. We know the Anubandha Chatushtaya is the main theme of ancient works. In Dashadhyayi, we can see the Anubandha Chatushtaya, what is Sambandha, what is Vishaya, Adhigari, Vishaya, Sambandha, Prayojanam. It is strictly, clearly clearly documented what is Adhigari, who is the aspirant, what is subject matter, what is Sambandha, what is the Prayojanam, purpose of this commentary that clearly documented. I'm not reading that. Next, on the first shloka of Brihajjataka, Bhattadari has shown the scientific truth that moon's water element, which is not shining themselves, but only reflects at night, only reflects with the influence of the sunlight on the concrete of ancient astronomical speculations. Yaha shashabhruto murtitve shariratve kalpitaha paritaha kalpitaha agama anumana pratyaksha rupaihi pramanaihi pramanikaihi paritaha kalpitaha Sushumna Surirashmis Chandrama Ityadi Shrutihi, and Manye Somam Chatatanu Mamagar Bhavardhya Vivaswan Shuklachayam Nayati Shanakaihi Swam Sushumnam Shubhaya. The quoting we can see there in Dashadhyayi. After that, after the theories of rotation of Earth of Aryabhata was refuted by the astronomers Bhaskaracharya, Brahmagupta, Varahamihira, and Lalla, but Keralite astronomers and astrologers never be refuted Aryabhata's theories due to the power of observation and experimentation experimentation. Nilakantha Somayaji has recorded the scientific, rational and experimental observational activities followed by Keralite astronomers. It as Nanu tapobhihi prasanno brahma aryabhataya brahmana paridhyadigam graha gananam sadhana bhutam sankhya vishesham upadidesha tadupadishtam punar aryabhataha sarve yathovadishtam eva dashabhir गीतिभिर निबबंध इति केचित् मन्यन्ते तस्य कुतः परीक्षणं ब्रह्मणः सर्वज्ञत्वात् रागद्वेषाद्य भावात् च अवितथत्व निश्चयात् इति चेत् मंदमेवं the last wording, that is we have to listen the manda maevam devata prasado mati mati वैमल्य हेतुरेव न च पुनः ब्रह्मा आदित्यो वा स्वयमेव आगत्य उपदिशेत. So observation and experimentation, that was the basic theme of Kerala astronomy. It is clearly that is said it clearly in Nilakantha Swamiyaji's work. Next one is Bhattadiri confirms and supports the theory of rotation of Earth of Aryabhata, the constant position of the sun in the middle of the universe, and the moon is shining with the help of the sun due to its watery body, etc. is set as Prakasha Shunye Jalamaye Chandramasi Reshmi Sampadada Saprakasham Chandra Shariram Utpadyate Iti Yuktya Siddhyati Arkendu Bhuvamarkasya Arkendu Jadi Arkendu Pujadi Dikchakrasya Mahiyo Rupam Paschimam Abhimukham Brahmati Jyotish Chakre Prangmukham Gachantas Chandradayo Graha Gola Rupaha Tatraiva Sthitasya underlined word tatraiva sthitasya prangmukhatasya gola rupasya ravehe. So the sun is constant. He accepted, he recorded it as prangmukhatasya gola rupasya ravehe reshmi sampatat graha gola rupaha tatraiva sthitasya. That is underlined word. Tatraiva sthitasya prangmukhatasya golarupasya ravehe reshmi sampatat suryabhimukha ardhabhagaha dipyante tatha cha aryabhataha bhugrahabhanam golardhani swachhayaya vivarnani ardhani yadhaparam suryabhimukhani dipyante. He when he explained anything, with the explanation, he quotes several informations from other texts, ancient texts. Time is an immortal factor in astrology. Astrology is known as Kala Vidhana Shastra. Time and its minute divisions are of extreme importance and of practical use in astronomy and astrology. Time is eternal, but is divided into many small units. In the Shantya, it can be seen that an important explanation of Bhattadiri on the verse Kalatma Dinagmanastuhinagu from the Vedangajyotisa, second chapter. The sun is Kala Swarupa, and so he is the pivotal of the universe. Years, ayana, weekly days, months, ritus are based on the sun. Movement of the sun in each zodiacal sign or Rashi causes ahorata. 30 ahoratas are equal to 1 month. 2 months are equal to 1 season. Or 6 seasons are equal to 1 year. But he gives a clear picture as above said terms as Revi Gativashat Apamandala Kalpana Divasa Kalpana cha Apamandalasya Dwadasha Rashudaya Vashada Ahoratra Siddhihi Trimshada Ahoratraihi Masaha Masadvayena Rutuhu Shadbhihi Ritubhihi Samvatsaraha Ityadi Kala Vibhaga Kalpana Hi Lavadi Pralaya Anta Kalo Nishpadyate. Ahoratra concept, order of 7 days in astronomy. While Bhattacharya comments the first chapter of Vedangajyotisa, Ahoratra concept is discussed. The duration of the rotation through the 12 rashis is known as Ahoratra, is of 24 hours. Bhattacharya said it as Meshashi Prathameshu Dwadasha Rashyatmakasya Chakraikasya Parikramana Kalaha Khallu Ahoratram. In the same context, Bhattacharya introduces the order of weeks, days. Weekly days, scientifically in simple words: Saturn, Jupiter, Mars, Sun, Venus, Mercury, and Moon is the respective order or Kakshakrama of planets downwards. The order of planets, Kakshakrama, is said, or Kakshakrama is said in Aryabhadeya as Bhanamathashanaischara Sura Guru Bhoma Arka Shukra Buddha Chandraha Yeshamathascha Bhumihi Murdhi Bhuta Apamadhyastha. That means first is nakshatra or stars, after that Saturn, after that Jupiter, next Mars, Sun, Venus, Mercury, and Moon, respectively. We can say the Kakshakrama. The first hora, which begins with the rise of the sun every day, is ruled by the planet of that day. For instance, the beginning hora of Sunday is that of the sun. The lord of the first hora of Monday is the moon, and so on. On Sunday, the first hora is that of the sun. Next, each hour is of Venus, Mercury, Moon, Saturn, Jupiter, Mars, respectively, as per the Kakshakrama. This order forwards repeatedly, and after that, the 25th hour, that automatically will be the day of moon. That is Monday. It's known as Monday. That means next day. Bhattacharya explained it based on the single word Dinesha of the verse Vedangajyotisa, second chapter, with the pramana of ancient words. Atra dinakratadayo varakramena kathitaha tatra kinchit prayojanam vidyade dinayamadhivatya vijnanam dinesha shabdena antyamshasya vareshaadhipatyam Uktam Grahaha Varanadhadayo Vasarasya Pramanashtabhagadhinadhaha Kramena Tatha Yamavatyascha Tat Panchamadya Ya Adyamshanadhasya Evashtamasya. So when he comment about this weekly order, he got a pramana from Muhurta Madhaviya. That is, I read just now. The order of the planets that given here. Say first one is Sunday. Sun, Venus, Mercury, Moon, Saturn, Jupiter, Mars, Sun, Mars. After that, repeatedly continue this order. Sun, Venus. After that, next after the 24th hora, the 25th, that means next day, that is of the moon. That is Monday. That is known as Monday. Next, Kala Hora. The word Kala Hora also recorded scientifically based on mathematical notations while explaining the word Charanabhivruddhita. The 13th verse of second chapter of Vedangajyotisa has introduced the Kala Pramana is of 1 hour. Astronomy and mathematically notations we can see there that is said as Atra Purvardhe Charanabhivruddhita Ityanena Kala Horadhivatya Pramana Muhyam. Charanaha Urdhvam Charanaha Artham Padona Rupa Sahitam Sardham Rupam Tadrupa Sahidam Sartham Rupa Dudayam Sarthagadegadvayam Prayaha Kalahora. So the measurement, duration of Kalahora that he explained though. And Bhattacharya mentions about the importance and accuracy of planetary calculation in astrology that should be considered and calculate minimum 3 times by an astrologer to confirm real result. He says that Yoge Grahanam Grahanaka Somayor Maudhyo Tadha Vakragato cha Panchasu Ishtanurupam Karanam Yadanvaham Tena Trivaram Ganayed Vihangama. Next, planets in the Shadhyaya. Astronomy in India is pure scientific and Indian astronomy. The starting point of the universe is the Earth due to living there itself. Earth-based observation is the pivotal point of astronomy of India. They were well aware on planets and their characteristics. The word graha is derived from the verbal root graha, which means to lay hold of or to grasp. Grinadi gativisheshanidi vibhashagraha ashtadhyay. Yad grinadi tasmad graha shatapada brahmana. The 9 planets are the Sun, Moon, Mars, Mercury, Jupiter, Venus, Saturn, Rahu and Ketu. In Western system astronomy, there is no Rahu. In astronomy, there is no Rahu and Ketu at all. Western astronomy does not include the Sun and the Moon in the list of planets, and the Sun is fixed luminary round. But Indian astronomy ascribed movement of the Sun also along the zodiacal or orbital because of the convenient usage of astronomical calculation. Bhattacharya records the order and position. One who observed from the Earth is clearly clarified as Saturn, Jupiter, Mars, Sun, Venus, Mercury, and Moon downwards, respectively, with the pramana of Aryabhatiya. He explained it by the verse Revijama redhirudhiraha parechaye kramasho bhavanti kilavikshanayathikaha. Asman asanna kramena shaneshcharad adhika vichyo guruhu guror adhika vichyo bhomaha tad adhika vichyo revihi ato adhika vichyo bhriguhu ato adhika vichyo budhaha ato adhika vichyaha chandraha tatha cha aryabhataha bhanamatha shaneshchara sura guru bhomarka shukra buddha chandraha eshamadhascha bhumir murthi bhuta avamadhyasthaha surya chandra. And after that Panchatara Graha, the concept of Panchatara Graha, that also mentioned the Surya Chandro Prakashaka Graho Punaruktaha Panchatara Graha Tadanandara Muktau Do Tamo Graho. Next, he says about 6 reasons connecting with the 9 planets. So the verse Shishiradaya Guru Shashurucha Nyagwadi Nyadishudyatsuva of Vedangajyotisa, 2nd chapter. Here, the winter or Shishira is to Saturn, spring or Vasanta Ritu is to Venus, summer or Grishma to Mars, monsoon or Varsha to Moon, autumn or Sharat to Mercury, winter or Hemanta to Jupiter. That's set as Shishiradaya Shashurucha Nyagwadishu Suva Sheni Shukra Ruthira Chandra Gurubhir Namadhyaktaroktahi Epihi Shishiradish. The planet Mars represents, after that his Vyakhyana is going on like this. The planet Mars represents heat. So that period of summer is of very hot. Moon represents water elements, and so it is monsoon time. Mercury represents autumn season, and so it is the time of purity. And the planet Jupiter represents winter season. The period is of purity of mind and intelligence. And hence, it is more supportive to grasp knowledge to person of astrology, on astrology. Eshu Radishu Grahanugunaha Abhyuhyaha Shitam Himadhikyada Tadrado Mandasya Dukhagaratwena Dukhagalaha Shukrasya Madanarubatwada Tadrado Madanavadeyaha Ruthirasya Agneyatwada Tadrado Taichniam Chandrasya Jalamayatwada Tadrado Varshagamaha Nyasya Vaimalyada Tadrado Vaimalyam Guruho Jnana Surupatwada Tadrado Buddhehe Satyugatvam. A.I.A.M. About the A.I.A.M concept, A.I.A.Namsha and A.I.A.M Bala, clearly we can see there in this commentary, the Shadhyaya, the day on which the duration of a day and night are equal, the entire world over is called A.I.A.M or equinox. The vernal equinox or Meshayana happens to be generally on 21st March of every year. The autumnal equinox or Tula-ayana will be on 23rd September every year. But as a matter of fact, there is a slight difference from the position of the point of the vernal equinox. The first degree of Mesha is the equinoctial point of the Rashi Chakra or zodiac, and the timing of the vernal equinox calculated at a particular area are called as Ayanamsha. In India, almost all great scholars accepted the system of fixed as the basis of astrological purpose. It is said that a certain period of time, the two chakras have a common beginning point, and that because of the slanting axis of the earth, difference in distance between the two occurred. The position of the earth vis-a-vis the commencing point of Mesha sign is generally reckoned 50.3 degrees further west. A.I.A.M is also very effective and applicable in Jyotish Shastra. So, Bhattacharya has described the calculation of A.I.A.M that even if Varahamihira has not explained in Brihad Jataka. Bhattacharya says that Atha A.I.A.M chalanam acharyena anukatamapi maya atra shastrandharad uchyate. After that, he exhibits different options of A.I.A.M calculation of different scholars, done by different scholars like Manitha, Maya, and Aryabhata. Although A.I.A.M is not mentioned by Varahamihira, A.I.A.M Chalana of Brihat Samhita is strictly followed by Bhattacharya too, convincing the difference of A.I.A.M between ancient and modern age. Ashlesharthad Dakshina Uttarayanam Reve Ardhanishtham. So Reve Ardha Nishthadyam in Brihat Samhita. Next one is Kadabayadi system is also applied in Dashadhyayi. The earliest occurrence of the Kadabayadi system, the general belief is that Vararuji, 4th century AD, who was the proponent of the scheme of this scheme. Some variant of Kadabayadi system can be traced back from the Aryabhatiya, 5th century. Khadvi Navake Swara Navavarge Navantya Varge Va. Actually, in Aryabhatiya we can see the Kadabayadi notations that may be influenced by Keralite scholars. Kadabayadi system is generally believed to be one of the major contributions of Kerala to Indian mathematics. Bhuta Sankhya is also an oldest digital method of India, but it was corresponded with only a few things. For instance, eyes corresponding to the numeral 2, Panjabhuta represents 2, numeral 5, it, and the like. Next one, in the Kadabayadi system, numerals are represented by letters. The great astronomer Kadathanadu Shankara Varma or Apputambura has implemented its rule that are given here. Nanya Vachashta Shunyani Sankhya Kadabayadaya Mishretu Pandya Hal Sankhya Nacha Chintyu Halaswara. Kadabayadi table is given the next. Kadabayadi notations applied in the Shadi. Kadabayadi system or parallel is very useful in astrology. This method is accepted widely by Bhattacharya in the Dashadhyayi many occasions. Some of them may be noted here while he explains the calculation of Madhyama Lagna. He quotes a verse of Lakhu Bhaskarya, Shunyadri Rasa Rupani Bhurandra Munindava Panja Agni Rathashino Meshadinam Nirikshajaha. The word Shunyadri Rasarupani is corresponding to the numerals 1670. Bhurandra Munindavaha representing to 1795. And Panjagni Randhra Shashino is corresponding to 1935. In this verse, Bhuta Sankhya system is also applied by Bhattacharya. Kadabayadi notations are applied here by him as Vishayadaya Panjadasha Ityetaha Kritagunaha Kritajivaha Kalajyam Anaye Dityarthaha. षष्टि गुणिता पंचनाडिका तृशतीसा षड्गुणिता सहस्राधिका षट्शत संख्याः प्राणाः ज्ञानोदय इत्यक्षर संख्या होरात्रेण हत्वा. Here the word ज्ञानोदय, nya 0, na 0, the 8, ya 1, corresponding to the numerals 18. 1800, and he speaks iti akshara sankhya, that represents Katabayadi system, that represents the Katabayadi system. In another context, Bhattadari has applied this system clearly. He gives a pramana as Kesari Bhogasheshohi. Each letter represents numerals. K, Ka, 1, Sa, 7, Ri, 2, Bha, 4, Ga, 3, She, Sha, 5, Sho, Sha, 6, He, 8, respectively. So the Katabayadi system, or Akshara Sankhya, that was very popular at the age of Bhattadari, approximately about from last of the 12th century AD. Kerala astrologers are still using this traditional system for mentioning Sputa table and in Kavita Kriya also. Very popular. Hence, it is believed to be one of the major contributions of Kerala in Indian astronomy and mathematics. And Panchanga description can be seen in Dashadhi. I am not reading that. And Sthanavala, positional strength, 6 types of power that based on the planets, that also scientifically included, interpreted in this commentary. That is given the, and not going, not reading that. And now concluding, the intellectual and practical activity encompassing the systematic study of structure and behavior of the physical observation and experiment, or a systematically organized body of knowledge on a particular subject, is known as science. Hence, any subject that if demonstrates its body or idea on the light of a systematic, rational, experimental, and observational, can be considered it as scientific in nature. The Shadhya is the first Sanskrit commentary on Vedangajyotisa of Vedangajyotisa from Kerala that exhibits a number of scientific theories and doctrines collected from the valuable ancient works to establish his point that astrology is absolutely not an independent area without astronomy and mathematics. But it reduces the present Vyakhyana, reduces the 26 chapters of Vedangajyotisa, having shown the scientific nature runs behind astrology, into 10 chapters on the ground of Kerala style. He has been followed a pure methodology here in this commentary with sufficient information scattered in ancient valuable works that help us to inspire to follow such type of scientific and observational approach on Jyotishastra, especially predictional science. He has recorded the attempt behind this commentary that only for his disciple on Jyotishastra. Varaha Mihira Hora Shastre Pradhamadhyayadarabhya Adhyaya Dashage Maya Viditarthaha Prayashavatra Vyakhyataha Uparidana Adhyayarthascha Kechite Vyakhyataha Nesha Panditya Prakatanaya Krataha Swapagatarthan Mandabuthaye Shishyaya Vadeshtuneva. The wording Sulpam Vritta Vichitram Arthabahulam of Varaha Mihira is supportive to follow the methodology applied in this commentary by Bhattadari. Thank you.
Thank you, Dr. Sujay Kumar sir. Thank you so much.
Thank you
for your wonderful presentation. Now I invite queries from the participants. You can ask questions. Anybody is having any doubt, you can ask. We had a detailed explanation regarding astronomy and astrology, so you have some doubts, I'm sure, so you can ask. Nobody is having doubts?
Okay.
Sir,
Yeah.
Yeah.
Okay.
am I audible?
Yeah, audible, very much audible.
Good evening, all. I am
Yeah.
Agila, BA Sanskrit student from Sri Krishnapuram V.T. Bhattathiripad College. My question is, astronomical works in Sanskrit are available from the time when science and technology were underdeveloped. Have any changes or errors been found in those works in the view of today's developed science and technologies? So, is it clear?
Yeah. I think so many new works we can see even now. For example, is that based on astronomy, based on mathematics, Driganidam. After the, what is that? The other Kunikanna Puduval, the last 18th century, he renovated the astronomical theory or mathematical theory. So many works we can see here, even now. Okay.
Yes, sir.
Not clear, sir.
Your sound is not clear, sir. Venkateshwara Pai, sir. I think Venkateshwara Pai, sir, was trying to ask some question. But his sound is not clear.
Yeah.
Yes, sir. Audible, but your sound has some disturbance. You can post your question in the chat box, sir. So we are expecting some query from Venkateshwara sir in the chat box. A small announcement for other participants. We have just shared the feedback form, a link of the feedback form. So all the participants shall fill that feedback form as early as possible, because your feedback is very important for us. So the link for that feedback form is given in the chat box. So all the participants, please fill that feedback form right now. I think I am audible, right? Yeah. We got the query from Venkateshwara Pai, sir. Dr. Sujay Kumar, sir?
Yes.
he had a comment, a small comment. Aryabhatta 1 uses his own system and not Kadambayadi.
Yes, sir, but we can see the similarity with the Keralite Kadambayadi system. Bhuta Sankhya is there, it's okay, but I said it very similar.
Yes. So with that, we can finish the session, right, sir?
Yeah.
Thank you so much. Now I call upon Mr. Sankeet Krishnan for delivering the official vote of thanks. Sankeet, please. Yeah, audible. Thank you, Sankeet. Thank you so much. So we have finished all the session of the day. Thank you so much for your kind cooperation. One more announcement for you. There is a slight change in tomorrow's time schedule. A small change in that time schedule of tomorrow's program. From 10 a.m. to 11 a.m., there will be session 8 by Dr. Venkateshwara Pai sir. So Dr. Venkateshwara Pai sir's session will be from 10 a.m. to 11 a.m. and then there will be paper presentation after that. And in the afternoon session, there will be session 9 by Professor Satyanad Kichanaswamy. Excuse me. So in the afternoon, there will be session 9 by Professor Satyanad Kichanaswamy from 3 p.m. to 4 p.m., which is followed by valedictory session from 4 p.m. to 5 p.m. So there is a slight change. Please note that. Thank you so much for your kind cooperation once again. Thank you and goodbye for the day. Thank you.